Good afternoon, everyone, and thank you for joining this webinar. We are expecting far more people than we have so far, but I'll continue going through the logistics while we're allowing them time to join in. My name is Ntuthuko Mkhize. I'm a range and forage scientist at the ARC, Agricultural Research Council in South Africa. But today I'm addressing you colleagues in my capacity as the Public Relations Officer of the Grassland Society of Southern Africa. I've been asked to drive today's show, and so I welcome you all to this Sundowner webinar number 7 in a series that started back in October 2020. The idea behind these webinars is to facilitate dissemination of science and encourage discussions around topical issues such as the issue of the impact of drought on the agricultural and wildlife resources, which is going to be the subject of today's talk. So just to give you an overview, the plan for this webinar is such that the speaker is going to run through her presentation for around 30 to 40 minutes. And this will be followed by a question and answer session that will be moderated or facilitated by my colleague, Dr. Cindy Sonkuna. I think she's already with us. Yes, I've seen her. So what I will request from you all, ladies and gentlemen, is that you please do not wait for the speaker to be finished before you can post your questions in the chat box. Just paste them as she presents so that we can deal with them later during the Q&A session. So maybe now with the logistics out of the way, all that is left for me to do is, I guess, to introduce our speaker. Our guest speaker today is Prof Emma Archer. Prof Emma is a professor in geography and environmental studies at the University of Pretoria. University of Pretoria, those who are from around will know that it is also famously known as the Turkish University of Pretoria. There she is showing it. So Emma was educated at the University of Cape Town and also in the United States. After completing her PhD in geography at Clark University in the US just over 20 years ago, actually she told me today that it was actually 22 years ago when she finished with her PhD. Emma secured a competitive postdoctoral fellowship at the International Research Institute for Climate Prediction within the Columbia University in New York, still in the US. So before joining the University of Pretoria, Emma spent many years at Wits University and also at the Council for Scientific and Industrial Research, which is also famously known as CSIR in South Africa. Her CV was circulated along with the invitation to this webinar, so I will not go through it all, but I think it is worth emphasizing, ladies and gentlemen, that Emma is working on sustainable agriculture, managed ecosystems, and also on climate, with a very strong focus on drylands throughout the SADC region and also throughout the continent of Africa. Emma has served as the co-chair of the Africa Assessment for the Intergovernmental Panel on Biodiversity Ecosystem Services. Those who attended the previous webinar, they will remember that our speaker then was Dr. Luthando Ziba, who was also a co-chair. I believe those two actually co-chaired this document. She has also served as the coordinating lead author on the forest and water assessment of the global forestry expert panels. So from this, ladies and gentlemen, to me, it is abundantly clear that Emma is recognized not only locally and continentally, but also internationally for her being a resourcefulness in her field. So thank you, Emma, for agreeing to speak to us on this important topic about drought, climate change, and the agriculture and wildlife sector in the Karoo. So we cannot wait to hear more about what you have to say. I give the floor to you, Emma. If you are ready, just
I am. Thank you so much.
Okay.
Tuka, for your extremely kind, far too kind words. To clarify, I did finish my PhD 22 years ago, but I was quite young. I was not 40. So let me first of all share my screen and thank everyone for joining us this evening. I know a lot of people are extremely busy. So, this little discussion that we have, we really appreciate you coming along. So if everyone can see my screen, I'm going to switch over to slide share. There we go. Everyone see my slides?
Perfect. It's showing perfectly. Okay. Thank you.
All right. Okay. So I've kind of combined if you like, a big picture presentation and a quite specific field presentation, because I think the one teaches us quite a lot about, I hope the one teaches us quite a lot about the other. So I'm going to be talking about drought, climate change, and the agriculture wildlife sector in the Karoo. And really the 2015-2020 multi-year drought, just some reflections about, some of what we know, not all of it by any stretch of the imagination, but also what I think we can learn. And also a little bit, I'll finish a little bit by, thinking about what we can learn by moving forward. So if I can give an overview, I'm going to start off by talking about how anthropogenic climate change has impacted on biodiversity, what those relationships are, and also a little bit about how it's changing the goal, what I think is really, really interesting, how it's changing the goalpost for successful conservation, for successful agriculture in the future. That is going to be coming from the IPCC Intergovernmental Panel on Biodiversity and Ecosystem Services report that came out in June 2021. And I just want to acknowledge one of the co-chairs, Bob Scholes, who sadly left us almost a year ago and was a leader and a mentor to so many of us. And then having set the big picture, I'm going to talk about the recent drought, how it impacted the Karoo, certainly the areas where we've worked, and a little bit about some reflections, what might the future look like. I'm aware that a lot of the photos that I'm sharing are not necessarily of the Karoo under drought conditions. I seem to take a lot more photos in better years than in worse years, but I will be finishing up by a photo that I took in October 2019. Okay. So, there we go. All right. So let's first of all talk about how climate change impacts biodiversity. And this is basically pulling together some of the latest findings for the planet that we put together for the IPCC IPBES report. So it's clear, and particularly clear now, that IPCC Working Group 2 released their report a week or two ago, that when it comes to biodiversity and ecosystem services, and of course that includes the ecosystem services for agriculture, that the impacts of anthropogenic or human-driven climate change have been documented in plants and animals. I'm a terrestrial person, but I always try and take time to emphasize that it's across marine and terrestrial and freshwater realms. So those impacts span all principal biomes, from rainforests and deserts to wetlands, and from the coastal marine to the deep ocean. We see climate change impacts on species at a range of scales, from populations and individuals to genes. I'm always having to remind my students that they like to think about climate change impacts on species at the population level. And I'm like, yes, but the genetic level is incredibly important and nowhere more important than to agriculture. Genetic diversity is a key tool in agroecology, whether it's wildlife, agriculture, cropping, livestock, all of those. We see climate change impacts on species at habitat and ecosystem scale. And of course, they can occur through changes in interspecies interactions, for example, and changes in competition, changes in predation, or changes in disease. There's some really interesting work that's being done now on how changes in interspecies interactions can drive, for example, zoonotic disease, one of which, of course, has changed the world dramatically in the last 2.5 years. And we can see climate change impacts on species through community composition, ecosystem function, and ecosystem structure. Sorry, a little bit of a delay when I change slides. All right. So there's a lot of spatial variation in climate impacts on biodiversity and ecosystem services. It can differ amongst the subregions of large or even continental and ocean scale areas. And that spatial patterning, and I know there's many, many people in the audience tonight who work on this in a great deal of detail, but that spatial patterning of sub-regional to local climates and ecosystems and the natural corridors for the migration of species basically affects how well species are going to be able to track shifting climates. And that's as important to biodiversity as it is for things like agriculture and wildlife management. Biodiversity hotspots and isolated ecosystems such as islands, mountains, lakes, enclosed seas and what we call seamounts, which is an underwater mountain formed by volcanic activity, very important ecologically to our marine biology colleagues, are particularly challenged. And why are they particularly challenged? Well, they tend to have few or no corridors that can facilitate the migration of species, and they're often spatially limited along both latitudinal and altitudinal gradients, which effectively limits the options for movement, if there are any.
Slight delay.
Slight delay. This worked perfectly earlier. Obviously, I need to change my slide before I finish speaking. It's so problematic. There we go. All right. So what might we lose? Well, species range shifts in response to climate change are effectively a primary multi-generational adaptation response to climate change. And if we look at the local consequences, that can be the extirpation of species in some parts of a species range, for example. So extirpation is when organisms or groups of organisms completely cease to exist. And maybe the addition of species at another. And this effectively leads to the changing patterns of species richness and all of those interactions as we spoke about. Habitat fragmentation, such as, for example, through land use conversion, which a number of people are very aware of, may turn hotspots or protected areas into islands and accelerate climate-related biodiversity loss within them. And then, of course, isolated ecosystems, which is something that those of us working in the high-altitude Karoo are very interested in, such as mountains, high-altitude areas, including islands, can become what we call evolutionary traps, where, for example, the migration of climate zones off the top of mountains or off of islands make it impossible for species to migrate to new locations with suitable climatic conditions. So what's incredibly important, whether you're working in the Karoo or whether you're working more broadly at the national scale or at the continental scale, is to understand that climate change, of course, climate change and climate variability, shorter term climate variability, are not drivers that act alone. They are part of what we often call a range of multiple stresses. So they interact when it comes to biodiversity and ecosystem services. Climate change and climate variability obviously interact with other pressures. So other anthropogenic pressures and direct drivers, and those include all the things that we're familiar with, land and sea use change, the direct exploitation of organisms, pollution, invasive alien species, a very, very clear example. All of this can and often does interact with climate change. And those interactions tend to result in complex and non-linear responses in biodiversity. And in the best known example, and one that's very important in the Karoos, also elsewhere in South Africa, increasing habitat fragmentation, and that can be, for example, due to infrastructural development, the development of mining, cities, roads and railways, the transformation of coastlines, for example, into ports, coastal protection, things like aquaculture, and importantly, and we had a very interesting discussion about this in the Karoo colloquium last November, the development of energy facilities, and those can include things like solar and wind farms, can themselves and often do impact biodiversity, but also can interact with climate change to impact biodiversity. And for the continent of Africa, if we look at indirect and direct drivers of change in biodiversity, including climate change and habitat fragmentation, if we look at the future scenarios, we see increasing changes in biodiversity under all direct and indirect changes for all regions and subregions of the African continent as we move towards the future. The one exception, which is an exception I always like to share, and I think it's incredibly important, is that the expansion of protected areas as a driver has had a beneficial impact on biodiversity. But all other direct and indirect drivers on the African continent, if we look into scenarios looking for the future, if we look at projections, we see increasing pressures on biodiversity. And of course, as we've talked about here, they also interact. So what can we learn from the 2015 to 2019? I can also say 2020, and I'll say a little bit more about that later. Multi-year drought in the Karoo. And I just want to acknowledge my co-authors, one or two of whom I think might be with us tonight: Justin Dutoit at Grootfontein, Christine Engelbrecht at the South African Weather Service, Tim Hoffman at UCT, my colleague Willem Lampman at UP, Johan Malherbe at the African Agricultural Research Council, and Mareike Stern, who's at Nelson Mandela Metropolitan University, all much cleverer than me. So we were very interested in the most recent multi-year drought in the Karoo. And of course, the Eastern Cape province, and in particular its interior Western Karoo region, where I do a great deal of work and where, for example, Justin and Mareike are based, has long been subject to periodic droughts. So droughts in this area are not new. And those have had significant implications for the agriculture, the wildlife management, and the conservation sectors. Many people know that from 2015, with some recovery in 2020, and the reason I'm kind of having a few caveats there is that there's been some debate about when the recovery really occurred. And some of us, post-publishing the paper in Journal of Arid Environments on which this is based, had to kind of engage in some debates around, you know, whether recovery had truly happened. Was it a 4-year drought? Was it a 5-year drought? But if we can take it as a multi-year drought from 2015, it was a severe multi-year drought and had negative impacts for a range of sectors. And that includes the extensive livestock farming and also the wildlife management and conservation areas, and also where, of course, you find these land uses occurring together, which is quite common, particularly in the area where I work, which is around the Snowberg. So if we look at the impacts of the drought, first of all, we look at the vegetation response to the multi-year drought situation. What we see here is 6-monthly cumulative vegetation, so NDVI, so percentage of PASG, basically, percentage of average seasonal greenness. NDVI is expressed as percentage of the long-term average. We see prolonged dry conditions and their effects. So we see the largest extent of the negative anomalies in the first and the second halves of 2019. If you look down towards the bottom, really, really significant. That December 2019 image is very, very significant. And we see that in late 2019, the drought footprint effectively expanded throughout the whole of the Eastern Cape province, for example. Now, our paper focused a little bit more on the western interior of the Eastern Cape province, but obviously, you know, some of the most severe drought, if we look just at vegetation response to the multi-year drought situation, was obviously in the Calvinia area. So there was extremely severe drought there. So we see prolonged dry conditions and expanding footprint to the east with very, very severe implications. Obviously, when we look at NDVI, we have to say there's a significant caveat here. It measures some particular things and it takes a lot of things not into account. So here we kind of look at a big picture in terms of what the multi-year drought situation might look like. Justin and Tim then looked at repeat photography because we wanted to look at a couple of different angles, and basically found using repeat photography that total vegetation cover was higher in 2020 than in 2019 and grass cover higher in 2020. One of the questions that we were addressing, which in retrospect maybe turned out to be a little bit of a red herring, I mean, we thought it was really interesting, was whether the drought was truly unprecedented, because the multi-year drought had, I'm sure people are aware, a lot of media attention, and there was as there often is, I think, with really severe droughts, a lot of discussion around, you know, this was the worst drought ever. This is an unprecedented drought. This is the worst drought on record. I'll say a little bit more about that later when I talk about some of our discussions on farmers. But what was interesting, and I'm pleased to see a couple of people in the audience tonight who've been looking at the trend of grassiness and grass-shrub interactions. The drought didn't seem to be severe enough to reverse the general trend of increased grassiness observed in the Karoo. That has obviously been a big discussion, and a number of us now are engaging, and there's been some wonderful work already published, including the PhD, Gina Arena's PhD that she completed at UCT last year, Gina, if I remember, looking at kind of rainfall and how things have been changing. So the drought was not severe enough as far as we could see to reverse that general trend of increased grassiness. Obviously, we would need to do updated analysis. But, you know, one of the limitations is that obviously one needs future research attention that looks on the responses of individual plants and species to the drought to kind of make this a completely full picture. We then looked at what the farmers said, because we felt it was incredibly important to look at, you know, livestock and wildlife production systems, how the drought had impacted them. So when we looked at drought and its impacts on livestock and wildlife production, and the reason I keep bringing the two together is because in many parts of the western interior of the Eastern Cape, you can find livestock production, you can also find wildlife, you can find conservation initiatives, you can find private conservation, and you can even find land where obviously all of that's occurring simultaneously. So the farmers in the area who were directly surveyed, interestingly enough, at the time reported few livestock deaths, but we think that's probably an under-response and under-reporting. We had significant COVID limitations on the surveys that we were able to undertake. And I did some subsequent work with the emerging agricultural sector that showed that there was significant livestock death. It just depended where you looked. What I can talk about, though, is the many indirect losses as a result of the drought. And that includes things like the loss of condition of livestock, which led to, for example, loss of production with low conception rates. So really low conception rates were reported, not just in commercial livestock. Farmers reported little or no milk production, so that increased, obviously, kids and lambs' mortality. So obviously, this is, some species are more vulnerable to this than others, but, you know, when mothers, for example, walk away because of no milk production and poor weaning percentages. Interesting, we often see higher livestock losses than normal due to higher pressure from predators, and this multi-year drought was no exception. Farmers also experienced loss of income due to destocking. So a further loss of income was also experienced due to having to feed animals to maintain their condition. Many of you will know that that can be a really, really significant investment. There were also a higher frequency of internal parasites, which both resulted in stock losses, but also when you had to undertake veterinary treatment, increased input costs. And strikingly, and this is really important if we look at wildlife and conservation, there was also loss of natural game reported. Especially interesting, I found this really interesting, especially kudu. So kudu are often part of secondary business on farms throughout the Eastern Cape and also in the Western Interior, for example, hunting and tourism. And game farmers in the area also reported low conception rates amongst game farmers due to the drought. And this was also evident on a lot of the private reserves. You see, Ikshan, you guys think I talk too fast, and now you've slowed my slides down. Let me see. Almost at the end.
Is it frozen?
Frozen, yeah, but it should in a moment. Sorry, I've noticed this is a problem when it wasn't a problem earlier today. Let me carry on. I'm just trying to unfreeze the sun.
Yeah, looks like it has moved. Oh, shame, your problems are not ending.
No, that's okay. I don't know why it keeps freezing. I know Zoom and PowerPoint occasionally don't interact. There we go. All right. So we saw significant losses of income due to poor stock and wool mohair prices during the drought. So, for example, mohair dropped by 30% in price. And the weights shorn were also lower. So, for example, there was a farmer south of Graafrenet who mentioned that what's called the clip was down 25%. Wool farmers showed similar results. In addition, the price of feedlot lands also decreased. Why? You know, inevitably, input costs on farms remained stable or even increased. One farmer, for example, mentioned that he'd effectively spent twice the value of his stock. And that's in terms of spend on feed and also on the costs in terms of loss of production over the last 4 years. So that's a very, very significant loss. I'm going to try to stop sharing and then share again. Sorry about this, everyone. See if I can sort this out. Okay, let me share screen again. All right, can everyone see that?
Yes, you just need to.
Oh well, sorry, I don't know why it keeps freezing. There we go. All right. So if we look at water, a number of farms reported that water resources, so for example, natural fountains, dams, and key boreholes, either dried up completely or were under significant increased stress. And I want to mention that in mid-2021, when I was in the area, a number hadn't yet recovered. What we see over here is the main sort of water furrow that brings water into River Thursday, for example. And in October 2019 and also in December 2019, that was extremely low. It was about as low as I'd ever seen. And that's generally a pretty reliable source of water. Some farmers, if we talk about financial costs, found that more pipeline was required for boreholes, which is really expensive, or had to make other investments to provide water for stock, and all of which obviously can be extremely costly. So we had started off the paper by asking whether the drought was truly unprecedented. And we'd kind of set this up because we thought it was a particularly interesting question. In retrospect, I think it might have turned out to be, as I said earlier, a little bit of a red herring, because a number of farmers quite fairly said, you know, well, why is it important if the drought was unprecedented? Is it not, you know, significant enough that it was severe? But anyway, I mean, scientifically, obviously, we are always interested to know whether something is an unprecedented climate event. And in terms of the direct question, feedback from the farmers differed. So one farmer mentioned that comparisons are difficult due to subjective perceptions of a drought, as well as the time periods in between. And this is someone who'd been farming for quite a long time. He explained that the 1966 to 1970 drought he felt was as bad, if not worse, for some farmers. That was a Snewberg farmer. It's clear, however, that the severity of the drought was localized and much worse on the flats as compared to the mountains. That came out fairly significantly. Some farmers did believe that the number of consecutive years of low average rainfall make the drought unprecedented. But I think what's important to say, you know, it's an interesting question scientifically, but what's important to say is that most farmers agreed that it was extremely severe and that there would be really a few good seasons required for recovery. Will we have that? Have we had that so far? How many are we going to need? I think for many of us working in the area, we're very much in a wait and see mode. So what can we learn and how do we move forward? So when we look at biodiversity and ecosystem services, including those ecosystem services that support agriculture, obviously climate change has very clear, severe implications. And this includes those implications of climate change for conservation ecosystem services that support agriculture. So let's ignore the unprecedented question for a moment and just say that the drought was considered to be extremely severe, with some, I would even say, a number of local impacts that were found to be really critical. The loss of production impacts, which I've referred to, and also the loss of income, which I've really referred to, it's very important to note that those have now, of course, been compounded by the economic stress and difficulties resulting from the COVID-19 pandemic, which obviously impacted the South African economy severely and has had really severe impacts on our rural economy. And that's likely to continue to impact the agricultural sector in the Eastern Cape for quite some time. So many of you who work on climate change will know that much of the work on climate indicates that severe droughts and their impacts are likely to be more severe in the future. So we are almost certainly going to see a higher frequency in the future of severe droughts. And I also want to say we are likely to see a higher frequency in the future of more multi-year droughts. You know, so there's a drought that occurs in a year, but then a drought that occurs over several years, we're likely to see a higher frequency of those. And some work is showing that we may already be experiencing a higher frequency. I'll finish up by talking about a little mini collection that we're putting together, where I hope we can bring together some of this work. So as a result, if we look at the impacts on conservation and agriculture of these multi-year droughts, it gives us a really useful perspective in terms of how the sector in this area is likely to be challenged in the years to come. So one of the things that we're trying to understand, and I think we're trying to learn from the work that's been done, is which land management areas have done best, which ones have been more vulnerable, and how can we translate that into understanding what resilient land management in these areas can look like in the future, given that we do know something now about climate implications for land and for biodiversity and for agriculture. How can we draw on that to understand best? And then I've included here purposefully, this was in October 2019 when I was doing some field work in the Kamdaburi National Park and surrounds, and that's what the dam next to Graaff-Reinet looked like. Some of you are very familiar with some of these photographs. So that was before the rainy season, really, in October 2019, in some of the most severe parts. So obviously there are important ecosystem services in terms of knock-on effects. How might ecosystem services, for example, like things like stream flow, be, excuse the howling in the background, very, very dramatic, I guess, when we talk about drought impacts. How might knock-on effects in terms of ecosystem services to settlements be? I want to finish up by talking a little bit about some work that we're doing this year. I asked Ikshan for permission. We are working on a new journal called PLOS Climate. So if you know PLOS One, this year we launched 3 new environmental journals in PLOS family. And this is our climate journal, PLOS Climate. And PLOS Climate has got what are called mini collections. So we're putting together a little mini collection, which is basically understanding climate pasts, because we think it's incredibly important to try and understand, as I've said earlier, what's happened in the past in terms of climate, and also climate futures in the Karoo. What can we expect, and what are some of the implications for some of the questions that I've mentioned? So just a little shout out to finish. If you have a paper in mind, or if you have a student who's working on a paper in this area, we'd be very, very keen to have you join us, and we'll be sending a call for papers out through, for example, GSSA and through the Arid Zone news list as well. So just please keep that in mind, and that's my little shout out to finish. And I think I'm going to leave it there. Thank you so much. I'm so sorry about the slow slide transitions. Just one of those Zoom PowerPoint interactions.
Thank you so much, Emma, for that wonderful and very informative talk. We are now going to move over to the question and answer session. So before we read the questions in the chat box, I would just like to encourage everybody, if you would like to engage with Emma through asking a question or making a comment, to please raise your hand. So our first question is from Debbie. So Emma, were there any reported bird losses?
Of what kind of losses, Debbie?
Birds.
Oh, bird losses. So there have absolutely been reports of bird losses. That's not an area I'm super familiar with. I mean, I can talk about poultry losses because I work a bit more on the agricultural side. So there were definitely poultry losses, both at the commercial and at the small scale. What we noticed was that some poultry species seem to do a little bit better than than others, but I'm imagining you're not talking about poultry. I'm imagining you're talking about wild bird losses. So there have been reports of wild bird losses, particularly in some of the really, really high temperatures. I don't know the findings for the Karoo as well, but I do know that there have been some significant findings around wild bird losses under very extreme temperatures. For example, my colleague Andrew McKechnie talked about some of the difficulties in some of the national parks in terms of very high temperatures. And Andrew recently presented some research, that shows that these extremely hot days, so there are extremely hot days and then also these persistently extremely hot days. So it's not just like one hot day, it's a series of extremely hot days have these, really, really significant implications for wild birds. And he's been looking into quite a bit of that mortality. He's got a number of students also working with the Fitzpatrick Institute at UCT looking into this. So yeah, I mean, very significant. Also, what's kind of interesting about that is that not just the direct impacts of heat, but also the indirect impacts. So for example, when you get this extreme heat, for example, when the rainy season is a bit late and you get these very extreme heat days, birds can forage differently, and that can also increase their interaction with predators. So it's these sorts of interspecies interactions that are also very significant. But yeah, I'm imagining asking about chickens.
I assume so. No, thank you very much, Emma. And I think you may have answered Debbie's question. Our next question is from Mike P. And he would say, great talk. Thank you, Emma. How did you define drought?
That's a really good question. So in the paper, we took care to define drought in a range of different ways. So my colleague who worked on the climate looked at a couple of different definitions of drought and looked at it in a number of different ways. We also looked at the NDVI because we felt it was important to look at, the vegetation conditions. If rainfall doesn't always directly translate, we looked at that as well. And then we also looked at farmer perception. So we looked at a range of different definitions of drought and effectively found that all of them showed that there was drought, but also that we saw this expansion of footprint if we looked at vegetation conditions into the Eastern Cape. So, but again, I want to mention that I didn't talk so much about the Calvinia area, but we have seen this really persistent drought in the Calvinia area that continued. And I'm cautious to talk about recovery, because in the paper we talked about recovery in 2020, but then a number of people did respond and say, look, I mean, if you look at this particular area, if you look at that particular area, including the Moordenaars Karoo, we don't see recovery. So it's always difficult when you look at kind of spatial variation and drought conditions. And you have to be quite careful when you use terms like recovery.
Okay, thank you, Emma. Well, Mike had a two-part question. So the second part of the question, does rangeland condition at the start of the drought affect recovery, particularly in a multi-year drought, and implications, and what are the implications for management?
I think it depends. I mean, here I'm going to talk as a livestock person. I think it depends completely on the type of felt and also a little bit on what you're farming. So, obviously if you're starting off the multi-year drought with really poor rangeland conditions, and you're also working with the kind of stock that are just a bit more vulnerable, are eating particular species, are not able to get out, we have to take grazing systems into account. I'm not going to get into here the big debate about the kinds of grazing systems that are more vulnerable under drought, although a lot of us have had a lot of debate about this. But so it's really, obviously the rangeland conditions at the start of the multi-year drought are really important. If you're starting with a bit of a buffer, obviously that will give you a bit of a buffer depending on how you're grazing and what kinds of livestock you're using and if you're doing conservation, if you're doing any rotation, for example. But with a multi-year drought like this one, even the areas where they started with quite a good buffer in terms of felt were ultimately very vulnerable in terms of kind of stock condition and poor rangeland conditions. So you can start with a bit of a buffer, but when you have a multi-year drought like this, and it really is persistent, of course, we can see that footprint expanding.
Emma, and I believe you have answered Mike's question. So our next question is from James Gam, and I believe the question is, how does rainfall amounts and distribution during this period compared to long-term records?
Hi, James. It's a really good question. So we haven't looked at that yet. We're hoping to look at that now. There has been some wonderful work done on climate histories and climate trends here. But in terms of doing a proper comparison with a 4 or 5 year multi-year drought, we haven't quite done that analysis yet. I've got 1 or 2 students working on that at the moment. So, watch this space. I mean, I found the comment, and I see someone in the chat line has also raised this it's always nice to look at the older farmers because they just have such amazing, but the 1966 to 1970 drought, where the farmer said, well, he felt that probably had been worse. So I'm hoping we can do some good comparisons there, and see if we can compare the 2 events. I don't personally remember that drought, but I do know that farmers in the area have spoken about the late 1960s in terms of being a drought that was extremely severe in the western interior of the Eastern Cape specifically. So yeah, it's going to be very interesting to see how those comparisons come out. But question of whether the drought was unprecedented, we found that incredibly interesting from a scientific point of view, but I did feel a little corrected by the farmers who said the fact that whether it's unprecedented or not, it might be of scientific interest to you, but really the big question is it was just an extremely severe drought, and that in itself is concerning enough. So I felt slightly brought up as a scientist, which I think is always very, very, very healthy.
Yes, no, thank you, Emma. Our next question is from Gina Arena. Hi, Emma. Thanks for presenting these interesting findings. Did you mention if these were insights from commercial farming systems? Any thoughts about the impact of these droughts on the communal farming systems in the area?
Hi, Gina. So that's a great question. No, I mean, I didn't give enough detail when I was talking about the survey. That was all large-scale commercial farmers. I then simply did some more, informal work with some of the smallholder agriculture, specifically around this Newburgh area. But the data wasn't robust enough to include in the paper. They were extremely hard hit. For example, one of the farms who I do some work with in the kind of Newburgh area were tremendously hard hit in terms of loss of stock condition, predation, which is always a challenge in the Campersburg area at the best of times. But then, of course, they saw an increase in predation, partly as a result of the multi-year drought, changing those kinds of interactions. And then water, I mean, they were so severely impacted by water. I mean, so if you look at the commercial farmers saying that they had been badly hit by having to, for example, find additional pipe for boreholes, it was extremely limiting for the smallholder farmers that I spoke to. But unfortunately, I wasn't able to talk to enough of them to really be able to include it in the paper. We're doing some follow-up work with them now. And I know there's a lot of people in the audience who've done a lot of work with smallholder agriculture.
Thank you, Emma. Mike P is back with the comment. So the farmer who says the drought was worse between 1966 and 1970, I believe he is saying there that indicates or reflects the value of former long-term monitoring.
Yeah, I mean, I can't agree with you enough, Mike. I feel every time I have the opportunity to sit down with a farmer who's been farming for decades and decades and decades, I just feel so privileged. And, it goes to this strong sense, I think, that many of us have that, the farmer's perception in terms of climate variability and climate change is just absolutely fundamental. in areas where the formal meteorological station coverage is not all that great, which is like where a lot of us work, few people know their local climate. And when you have the opportunity to sit down with someone who has that kind of historical perspective, it's just absolutely invaluable. Sadly, you know, inevitably working with populations of farmers, they're aging populations, but the opportunity to capture some of this is just so great. We feel incredibly privileged.
Yes, no, I agree. Thank you, Emma. We've got a comment from James Gambisa. So great presentation, Emma. So he's very happy. And then we've got a question from Michael Wallace. Hi, Emma, good stuff. Any thoughts on the impact of the locust outbreak so widespread in the Karoo?
I mean, it's a little bit off my cabbage patch, Mike, but I mean, the brown locust outbreak, I've done a little bit of, in the areas where I work, it's been phenomenal. And also Free State has been hard hit, parts of the Northern Cape have been hard hit. Obviously there is an argument that the climatic driver is these kind of very high rainfall, summer rainfall seasons. I know there's a number of people working in the modeling who are not sure if that's the whole story. But you know, it does seem to, I think the last significant outbreak we had was over a decade ago. So there is an argument that it happens every 10 years or so and is associated with these high summer rainfall seasons. Yeah, I mean, I'm not a brown locust modeler myself, so I'm not absolutely sure. I think it would be interesting. I know that the Agricultural Research Council years ago did work around an early warning system for brown locust monitoring. I haven't seen the updated work on that, but it would be really, really interesting to see it because a number of farmers have been asking about it. And I also sit on it's kind of like an agricultural think tank that the church has put together. It's chaired by the Methodist Church, and talking to their congregations about what's been happening in terms of farming in the area. So there's many, many smallholder farmers represented on that forum, and there's been a lot of questions around the brown locust outbreaks, including, you know, what we can do about it, which is very difficult. So it's obviously had very, very severe damage, and certainly has had a lot of severe damage amongst the emerging agriculture in the areas where I work.
Thank you, Emma. Now we've got a question from Peter Theron. Do you expect that there might be changes in plant species composition, a potential decrease in perennials, especially shrubs, and would that potentially affect long-term grazing capacity? If yes, do you believe that there are effective management practices to mitigate this?
Okay, so here I'm going to go to the repeat photography analysis. I don't know if Justin's on the call. I know he was going to try and dial in, if there were no connectivity issues. So we didn't see that from our analysis. I mentioned that we didn't. From the analysis from the repeat photography, we didn't see that there had been, you know, there's this long-term trend of increased grassiness where there's been a great deal of work done. A number of us are still trying to understand some of the drivers of that. So we don't see that. If I can turn your question around a bit, let's rather say, how good has the recovery been and how can we best support that? The recovery has been, as I mentioned earlier, uneven. Partly the recovery has been uneven because the recovery of rainfall conditions has been uneven, which is kind of what we would expect in any case. So there's some areas that really have not recovered well at all in terms of rainfall. But, you know, there's been a lot of very good work that's been done on understanding what types of land management are going to be more vulnerable or more resilient under these kinds of multi-year drought conditions. What was interesting to me about the work that we did, so I can only really speak for the very specific area that we worked in terms of the farmer surveys, but was that game production was also affected. So that tells us that commercial stock production is not the only agricultural system that's vulnerable to this kind of multi-year drought, and that we need to be looking at sustainable land management techniques. Sometimes I think we spend a lot of time talking about only commercial stock production systems, and we kind of leave the private reserves and the game production systems out of it. But I'm hoping that some of our findings shows that you can't do that. You need to take both into account when it comes to looking at sustainable rangeland. I mean, I know this is old hat for everybody probably in the seminar, but you know, if you get into looking at the broader narrative and the broader discussion, that isn't always particularly clear.
Yeah, thank you, Emma. And we've got a question from Eugene Moore. Adding to the locust question, is there any work that locusts might be key biogeochemical recyclers? Thus, killing them, we are preventing this long-term biogeochemical recycling.
Eugene, that's a really interesting question. So yes, I mean, locusts play a range of really important ecological roles. So it becomes complicated. So for example, when I was in this discussion last week with this agricultural think tank with people from all over the SADC region, and people were saying, well, you know, what's some of the advice in terms of using chemicals to get rid of them? Of course, you know, it's very difficult. I mean, I'm very hesitant as a scientist to come in and say, we should not be getting rid of brown locusts. But of course, it's very important to understand the role of ecological services that they provide. And yes, they do provide a wide range of ecosystem services. Yeah, I'm a bit cautious. We had a bit of a debate about the use of chemicals to control brown locusts last Friday. And again, it was a forum where there weren't a lot of scientists and there were a lot of farmers, which I think is very good for us scientists to be in those sorts of arenas. So I had to kind of be quite cautious in popping up there and saying, well, we shouldn't use chemicals, particularly when we've had an outbreak of the severity that we have had. But yes, I think good awareness about the range of ecosystem services that, for example, brown locusts can provide is incredibly important to allow people to make perhaps more informed decisions in terms of control. And I see someone is mentioning, yeah, I mean, there's been some really, really great analysis that's been done on this in terms of brown locusts and maybe some more environmentally friendly techniques for control.
Thank you, Emma. It seems we've got a lot of locust specialists here. The next question is from Ganta. So how did the 25th sun cycle reflect in the definition of droughts? Did locust migration follow flats or mountainous regions via lignin being responsive to soil water systematics? That is the multi-year drought.
I'm not sure I totally understand the question. So the brown locust migration has really been more associated with the recent quite kind of widespread rainfall conditions we've had over the last summer rainfall area. Do locust migrations follow flats or mountainous regions? I mean, I've seen severe locust migrations in flats areas, and I've seen extremely severe locust migrations in some very high altitude mountainous parts of the Sneeuwberg. One thing I think that is interesting, if I can turn the question around a little bit, is this. I would be interested to know if the brown locust outbreak, what happens? I mean, there was that question earlier about what happens if you have good rangeland conditions, or what's the influence of the rangeland conditions at the beginning of the multi-year drought. I'd be interested to know if locust migrations, we know that they may be associated with higher rainfall seasons, but did the prior multi-year drought have any impact? So might this be what we call a combination event, so that you have a prior drought followed by a good rainfall season? Could that be a predictor also of brown locust outbreaks? We tend to get very caught up in just looking at the good rains in the summer rainfall season, but a number of us are wondering if maybe the prior drought is also a predictive factor. Yeah, so it's another student research topic that would be extremely interesting to look at.
Thank you, Emma. So lastly, we've got a comment. So we don't have a name who it's from, but it says, if you are interested in the long-term changes in perennial shrubs and grasses in the Eastern Karoo or Southern Free State grasslands, then Gina Arena's PhD is the best analysis around. So you can listen to her views on the following YouTube seminar. So we've got a link as well.
I totally agree.
Sorry,
yeah, Gina's on the call. Yeah.
Yeah,
Oh, is that you, Tim? Go ahead.
It's from me, Tim Hoffman. I was Gina's supervisor. So I don't know why my name's not coming up there. Sorry, everybody.
I was going to say, Darren, you're quite right, Tim. Gina's PhD is incredibly useful and an absolutely fantastic and really robust analysis.
Apologies.
No, that's okay. Thank you so much, Tim. And thank you, Emma, for the wonderful talk and for other wonderful discussions that we've just had. I am going to allow Untutugo to wrap up. Thank you.
Thank you.
Thanks a lot, Cindy, for handling those questions and answers sessions, that session so professionally and so well. And maybe let me also thank Erica, Debbie, and Ikshan for their technical support behind the scenes. Emma, I don't know, we cannot thank you enough. On behalf of the GSSA, I would like to really thank you for such an insightful and interesting presentation that touches a lot of people's lives who's here, because it doesn't matter whether they're from agriculture or wildlife conservation. Drought still has an effect on you and your clients and the people that you are working with. So we really thank you for your time and for your expertise. We really appreciate your making time to talk to us today. As a society, we really appreciate and then hope that we can keep in touch with you. We would like to see you in our coming congresses in the near future. I don't know. It's
definitely, especially nice. Since it's an all-dam. I think it's going to be a lovely meeting.
Yeah. Now things are getting more and more physical, so we hope to stay in touch with you and hope to see you at our annual congress, at least in this coming July. Ladies and gentlemen, thank you all for your time and participation in this webinar. Please remember that your attendance of such webinars counts for CBD points if you are registered with SACNAPS. You will also, we will also have, I think we have one more seminar or webinar lined up for you colleagues in 1 or 2 months. So that would be the last one before our Congress. So please watch your inboxes for further details. Lastly, July is approaching soon. So please register and submit your abstracts for the GSSA Annual Congress taking place in the Free State this year. We hope that everything is going to be physical. Maybe also, let me just say that with those words, I would like to say goodbye and good evening to everyone. Thanks again, Emma, for your time and expertise.
Thank you so much for having me. I really appreciate it, and I'm looking forward to the Congress in July.
Thank you. See you then. Everyone else, thank you very much for your participation, and we hope to see you again soon.